Well, welcome back. We've got an exciting topic tonight. We're going to get back into a lot of algebra. And our topic tonight is called relative extrema. Now, that at the end might be throwing you off. That is just plural for extremes. So what's that is referring to is relative maxes and relative mins. Okay, so don't let that word extrema throw you off. That just means both a relative max and a relative min. Now, we have what we call relative and absolute extrema. So relative max, absolute max, relative min, and absolute min. And there is a big difference between the two of them. So I want you to sketch this picture out as best you can. I know it's a little blurry at the moment, but just sketch it out and get the idea. And let's label our relative versus absolutes. So underneath your picture, copy this definition down. A relative max occurs when a point must be greater than the value to the left and the right of it. Okay, so a relative max happens when you're greater than to the point to the left and right. So obviously B could be a max. I mean, I'm not going to consider A at all, but B could be a max. Is B greater than the point to the left and the point to the right? I would say yes. So let's label B as a relative max. Okay, do you have another relative max? Well, if I go to E here, E is greater than the point to the left and to the right. So I have another relative max at E. How about the word relative min? It's the same idea, except I would look for a min value instead of a max. And again, the point this time must be less than the value to the left and the right. So if I look at maybe D, okay, it's smaller than the left and the right side, so I would have a relative min. If I look at point F, I hope you would agree, the same thing, a relative min. Now you might be thinking that's pretty obvious. That's probably what you've talked about your whole math career, maxes and mins. But I just want to be clear. Point A cannot be a relative min, okay, because by definition it would have to be smaller than to the left and to the right. Well, it's clearly smaller on the right, but is there anybody on the left? No. So A could not be considered a relative min. It has to have somebody on the left and the right to be relative. Now, how about the word absolute? When I say absolute, it's a must. Is A absolutely the lowest point? You can't have two absolutes. You can only have one. Is A absolutely the lowest point? I would say yes. So A is an absolute min. Okay, it does not need somebody to the left and the right. It is absolutely the lowest point. Now, how about our absolute max? What do you think about G here? Is G absolutely the highest point? Well, your gut might be telling you yes, but is there actually a point at G? Okay, I would say no, there's an open circle there, so G is not my absolute max. Now, I'm going to say that B is a little higher there, so B could also be my absolute max. Alright, it is absolutely the highest point. So just to be clear, relative needs somebody to the left and the right, kind of like the min or max you've always been talking about, and absolute could be an endpoint. So before we get into any real algebra, I really just want to focus on the words increasing and decreasing. So again, you've got 3 sketches we can put in our notebooks. And the question is, basically I want to talk about where this function increases, decreases, and whether it has a max or min. So if I look at my first graph of f of x, okay, you are always walking left to right. All right, that's not an option. As you start on the left-hand side, are you going up or going down? Well, if I'm walking on this, clearly I'm increasing, I'm going up. So I would say I'm increasing from negative infinity until where? Where do I stop going up? I would say I have a relative max at 1, and all of a sudden I start to come down. So I would say from negative infinity to 1. Now, this question always, makes people think here, do you include 1 or put a parenthesis around 1? Well, at 1, are you increasing or are you at your highest point? I would say you're there, so you don't include 1. You are no longer increasing when you get to 1. Then I would say as soon as I get to 1, I start decreasing. So I would say from 1 to positive infinity, I start to decrease. Again, I'm just saying I walk down. All right, so what does that tell me? I've created what we call a relative max. All right, so let's just be clear. This is a relative max. It is higher than the left and the right side. And my question is, what do you know about f prime at that relative max? So I want to say f prime of x at x equals 1 is what? And now when I say f prime, of course, you're thinking slope. What is the slope at 1 if you put a tangent line there? Hopefully you're saying f prime of x equals 0. And that's my goal. That's kind of what I want to do for each picture here. Example 2. All right, walk left to right. If you walk on the left, are you increasing or decreasing? Are you going up or down? So I would say I'm increasing from negative infinity until negative 1. Again, I'm not including negative 1 because once I get to negative 1, I am no longer going up. I am at my highest point. And then I'm decreasing from negative 1 to positive infinity. All right, so at x equals negative 1, okay, do I have a max or min? All right, I would say I have a relative max. I have a high point. But what is my slope, f prime? Remember, f prime means slope. What is your slope at negative 1? Hopefully you're telling me you can't draw a tangent line there. Remember, if you try to draw that tangent line, it could kind of teeter-totter. So I would say at x equals negative 1, f prime of x does not exist. Okay, remember, it comes to that cusp, so our slope does not exist. All right, last one here. I would say I'm increasing from negative infinity until 3, and then decreasing from 3 to infinity. Again, I've created what we'll call a relative max. And my question is, at x equals 3, what is f prime? Can you draw a nice horizontal tangent line, or is it going to teeter-totter when you try to put your line there? Well, of course it's going to teeter-totter, so I would say f prime of x does not exist. And in my head, remember, I'm thinking that it comes to a corner there. That's my corner of the right angle. My cusp was that previous one. Now, before we go on, I want to show you that every function increased and then decreased. Increased, decreased, increase, decrease. And every time I went from increasing to decreasing, I made what we call a max. If I increase, then decrease, I create this relative max. All right, likewise, let's talk about our relative mins. You'll notice that it's also called a local min. I think the AP uses relative most often, but they do mean the same thing. So what does my function do first? Does it increase first or decrease first? Well, again, if I walk left to right, I am decreasing, then increasing. So let's start with the decreasing. I would say from negative infinity until negative 2. Remember, don't include it. And then I increase from 2 to infinity. At x equals... Oops, that should be negative 2, sorry. At x equals negative 2, what would you say your slope is? Does it exist or not? Well, can you draw a tangent line there? Absolutely, it's not going to teeter-totter. I would say my slope at negative 2 is 0. Okay, but notice I did decreasing, then increasing. Next example, I'm increasing. Okay, so I'm decreasing, now I increase. I'm increasing from 0 to infinity, and I'm decreasing from negative infinity to 0. And if I try to draw my tangent line at x equals 0, again, it's going to teeter. I could put it a bunch of different ways. It came to a cusp, so I know f prime of x does not exist. Hopefully you're seeing that same example in this last one. I'm increasing from 1 to infinity, decreasing from negative infinity to 1. If I try to draw that tangent line at 1, I think you'll see that it'll teeter. You can put it a bunch of different ways. So f prime does not exist at x equals 1. Now again, my whole point was to show you that if you decrease then increase, decrease then increase, this time you create that relative min. Now that all might sound extremely simple to you, and if it does, that's a great thing. I think we're ready to get started in our algebra. So the next definition you have to be aware of is the term critical points. And let's star this in your notebook, maybe put a big box around this. Pretty much for the next couple of weeks, all we're going to be doing is finding these critical points. So our definition that we should have down word for word is critical points are the x values where the derivative of the function is 0 or undefined. Since all these places are relative or local, extrema could occur. And that's what we just showed you in the past 6 examples. Anytime we had a slope of 0 or didn't exist, that is referred to as a critical point. And again, we use the x values. So question 1, find all the critical points. Alright, so all we did is we said we have a critical point when our slope, so when f prime of x equals 0, or f prime of x does not exist. Okay, and that's got to go through your head every single time, and let's write it down underneath the problem. I have a critical point when the slope is 0 or does not exist. Now, typically the only time I'm going to get it doesn't exist is if I have a fraction. Okay, obviously if the denominator equals 0, you have this undefined or does not exist slope. And then sometimes in my trig problems I might get, undefined parts such as tangent or secant or cosecant. So my first goal is to set the derivative equal to 0. So I'm going to find f prime of x. So we get a nice 2x plus 8. Okay, and it says set that equal to 0. So 2x plus 8 equals 0. Okay, notice 2 easy steps. Take the derivative, set it equal to 0. Solve for x. Subtract the 8, divide by 2, x equals negative 4. Okay, so I just want you to highlight this and say we have found our first critical point. Notice I didn't have to worry about the doesn't exist section because I didn't really have a fraction or a trig function. Alright, next example. Let's find all the critical points. Let me just slap an f of x equals here. So find that critical point, setting this derivative equal to 0. Let's see, so I get 6x squared plus 6x minus 12 equals 0. And you can write it all in one line like that. F prime of x equals this chunk equals 0. And I'm going to pull out a 6 there, so I'm going to say that's x squared plus x minus 2 equals 0. Make sure you're carrying that equals 0 down. Now don't lose your 6, of course, that stays out in front. X plus 2, x minus 1. If I tee that up, watch all 3 pieces. Does 6 equal 0? Does that make any sense? Of course not. Here I get x plus 2 equals 0, so x equals negative 2. And x minus 1 equals 0, so x equals 1. So I actually have 2 critical points in this example. This, of course, got rejected. Now we're going to get into what we call the first derivative test. So here are the rules. Again, these should all be in your notebook. Let's get them in nice and neat. Pause it if you need to. Step 1, find all the critical points. Well, that's pretty straightforward. That's what we just did. That's when f prime of x equals 0, or, don't miss the second part, f prime of x does not exist. Make sure there's 2 things there. Then we're going to create what we call a sign chart that is labeled. Alright, so if you've taken your pre-calc before, this is the way we're going to do it this year for the AP. 3, test all values in f prime of x. And 4, state your solution. Now, I'm going to have you copy down one more thing about our first derivative test before we actually dive into an example. So again, if you need to pause it, go for it. To find, and again, here's how you find this use this first derivative test. To find increasing and decreasing intervals, test the intervals between the critical points to see if f prime is positive or negative. Intervals in which f prime is positive indicate f of x is increasing. Intervals in which f prime is negative indicate that f of x is decreasing. Now, I think that makes a lot of sense. Picture a parabola. Okay, if this is f of x, what do you know about f prime here? Well, f prime is positive. Okay, the slopes are positive, and that tells me that f is increasing, and that's what this says. If f prime is positive, that means f is increasing. Look at f prime on this side. The slopes are negative. So if f prime is negative, that should tell me that my function f of x is decreasing. And then finding relative or local maxes and relative local mins. If the derivative of the function changes from positive to negative at a critical point, there is what we'll call a relative max at that number, assuming the function is continuous there. If the derivative changes from negative to positive, we'll say there is a relative min at that critical point. Alright, now that that's copied in your notebook, we're ready to dive into some examples. State all relative extrema and find the intervals where f of x is increasing and decreasing. So again, this word extrema is plural. It wants you to state both maxes and mins. And of course, that's relative maxes and mins. Alright, so if you look back at those steps you just copied down, the first step said find all critical points. So I'm going to take the derivative and set it equal to 0. 2x minus 6 equals 0. Add the 6, divide by 2, x equals 3. Alright, step 1 is done. Step 2. It says we're going to create a sign chart and labeled correctly. This is not an option for our AP. So here's what we do. Here's what a sign chart is. Basically like a number line. The top always gets labeled with f prime. The bottom gets labeled with f. Okay, and that's why I said we're not skipping this labeling step. It is not an option on our exam. Your critical points go on the number line. Well, we only had 1, so I'm just going to stick x equals 3 on there. Okay, now, all you do is you test a number. So if you look at our step, step 3 says test a number. in f prime. Okay, so I'm basically going to plug any number to the left of 3 in f prime and anybody to the right of 3 in f prime. And you don't have to write them down, I will for you. I'm going to test 0 on this side, that's to the left of 3, and I'm going to test 4 on this side. And I want to be clear, I'm plugging them into f prime. So, the other thing I want to state is I don't actually care what I get, number-wise. I care whether it's a positive or a negative. So here's my f prime function, and I'm just plugging in 0. I have 2 times 0 minus 6. Don't even tell me what the answer is, just tell me whether it's positive or negative. 2 times 0 is 0, minus 6 is a negative number. You put a negative sign there, one negative sign, one big one, and you always show then that this function is decreasing. So a nice line with an arrow on the end. Now we'll plug in 4. Again, don't tell me what the number is. I want to know if it's positive or negative. 2 times 4 minus 6. 8 minus 6 is a positive number. You put a plus sign there, nice big one, and you put an arrow on the end, like this, showing that your function is increasing. Now this describes your function to a T. Look at this sign chart that we made. Okay, the top row talks about f prime. And the bottom row describes what f is now doing. So here's what I can say. F is increasing. Whoops. F is increasing. And here's what you're writing down. It's not an option. This is what the AP exam will be looking for. We have to justify everything we do. On the interval, so if I look at my arrows, this is decreasing, this is increasing. So 3 to infinity. Now I have to say why. Why do I know that it's increasing? Well, now you look above and you say, because this is positive and that's f prime. Because f prime of x is positive. Now the easy way we're going to say that, of course, is to say that it's greater than 0. And this is 2 points on your AP exam. Let's make sure it's labeled perfectly. F is increasing from 3 to infinity. F prime of x is greater than 0. Let's do one for decreasing. F is decreasing on the interval negative infinity to 3. How do I know that? I look at this sign chart. I have my arrow going down for decreasing, talking about f, negative infinity to 3. And how do I know that it's decreasing? Now you look above. F prime, we're talking about calculus now, is negative. So I would say f prime of x is less than 0. Now, I've talked about increasing and decreasing. I need to state any relative extrema. So the question is, do I have a relative max, min, or both? Well, look at your arrows. Like this should be a no-brainer. Follow the arrows. It went down, now it went up. Look at my arrows. Did you make a max or did you make a min? Clearly, I have a min. So f has a min, a relative min. And you can abbreviate rel min, that's fine, that's full credit on their exam, at x equals 3. Okay, so that's 1 point for that. Now I have to justify. How do I know I have a min? Well, remember it's calculus, so say something about the derivative. F prime changed from negative to positive. And again, that's what they're looking for. Okay, don't try to make up your own lingo here. It should all be the same thing. F has a relative min at x equals 3. F prime changed from negative to positive. And it's that simple. So we'll try a few more together. All right, next example. F of x equals x to the 4th minus 8x squared. All right, you should be able to pause this, and your first job is to go get any critical points. So pause it, see what you get. All right, what do you think of my critical points? I'm hoping you have the same thing. Simple derivative of 4x cubed minus 16x equals 0. Make sure it says equals 0. That'll be worth a point. They're looking for that setup. I pulled out a GCF of 4x. Okay, then I'm left with x squared minus 4. I factored that one more time to x plus 2 and x minus 2. So I have 3 critical points when I set each piece equal to 0. On this side, of course, I get x equals 0, 0 divided by 4, x equals negative 2, and x equals positive 2. All right, so on my sign chart now, I need 3, and they go in order. Negative 2, 0, and 2. Not an option to label this. F prime goes on top, F goes on the bottom. Okay, now, you're just picking numbers and plugging them in. So the more critical points, the more numbers you have to test. I'm going to test a negative 3 here, a negative 1, a positive 1, and a 3 here. Now again, some people make this a lot harder than it needs to be. box your derivative in. Okay, your factored form. Find the easiest version. And I think factored form is the easiest. Box that in. I don't care what number you get. I care whether it's positive or negative. So watch how I do this. I'm going to start with my 3. Okay? I'm going to plug this 3 into 4x. Don't tell me the number, just tell me if it's positive or negative. 4 times 3, I'm going to put a plus sign right above here. Now I'm going to plug 3 in here. 3 squared minus 4. 9 minus 4 is a positive. And what is a positive times a positive? Positive. Okay, don't worry about actually multiplying the numbers for the most part. Just figure out what sign you're going to get. Let's plug a 1 in. Okay, I'm going to plug a 1 into 4x and I get a positive. I'm going to plug a 1 into this term. 1 squared is 1 minus 4 is a negative. A positive times a negative is a negative. Plug a negative 1 in. 4 times negative 1 is a negative. Negative 1 squared is 1 minus 4 is a negative, and a negative times a negative is a positive. Plug a negative 3 in. I get 4 times negative 3 is a negative. 3 squared is 9 minus 4 is a positive. A negative times a positive is a negative. Okay, now finish your sign chart. Describe f. If f prime is negative, f is decreasing. If f prime is positive, f is increasing. If f prime is negative, decreasing, and then again, increasing. Okay, this sign chart needs to be perfectly labeled. It is not an option. F prime and f, correct signs, correct arrows. Now, I want this to be clear to everybody. It's not Algebra 2. These will not alternate on 90% of the problems, okay? So don't think if you know this is negative, it's going to go negative, positive, negative, positive. It is not Algebra 2. Okay, these are going to change quite a bit. We just got lucky there. So let's describe what we have. Let's talk about the intervals where f is increasing. I would say f is increasing, and now you just describe where your arrow went up. From negative 2 to 0, and from 2 to infinity. And how do I know that? Now justify. Justify with calculus. Describe f prime. F prime is greater than 0. Okay, it's positive. Describe where f is decreasing. Look at your down arrows. Negative infinity to negative 2, and 0 to 2. How do you know it? Well, describe with calculus. F prime is less than 0. All right, let's talk relative maxes and mins. How many do we have? Let's just follow the arrows you drew. It's that simple. Relative max. Okay, went down, then up. That's a min. Now I'm up, then down. That's a max. Down, then up is a min. If you follow the arrows, you really can't screw it up. If you even draw in what's happening. There you go. We have a relative max at x equals 0. Justify. How do you know it's a max? Use calculus. F prime changed from positive to negative. That's what we're looking for. I have relative mins at x equals negative 2 and x equals positive 2. How do I know? Use calculus. F prime changed from negative to positive. And again, that's simple. Alright, let's throw another one up there. Get all critical points, make a sign chart. Let's see how fast we can go. Take your derivative, set it equal to 0, get your critical points, see if they match with mine. So hopefully you've paused it and you've checked mine. I brought my 3 down, kept my, whoops, didn't mean to do that. Brought my 3 down, kept my inside, raised it to the second, derivative of the inside is 2. 3 times 2 gets me 6 times that quantity squared. So we should be pretty good at the derivative part by now. Tee it up. On this side I get 6 equals 0, which means nothing to me, that's garbage. On this side, I set that quantity equal to 0. To get rid of the square, I simply just square rooted both sides. Square root of 0 is 0, and solve for x. So I actually only have one critical point to test. Okay, so I'm testing 3 halves, label f prime and f. And you just need to pick somebody bigger and smaller. So I love 0 if I can use it. And again, say to yourself, 2 goes into 3 how many times? 1 and a little more. So 2 is a safe number to pick on this side. Now I can't stress enough, I don't care what the number is. I care whether it's positive or negative. So I'm going to pick the most factored version I have, kind of box that in. And that's where I'm plugging this in. Alright, is there any place to plug the 2 in on this side? No. So I basically get 6, I get a positive times whatever this turns out to be. Well, think about this. No matter what number you plug in, you're doing what to it? You're squaring it. And anytime you square something, you're going to get a positive. So it doesn't matter what I plug in, I better get a positive number. It's not possible to get a negative number. When I square something, I get positive times a positive 6 is always positive. So that tells me I've got a positive when I plug in 0, a positive when I plug in 2. This function is never what? It is never decreasing. Now watch how this gets written up. Oops. F is increasing. You can't say everywhere. I want you to think about that. You can't say everywhere. The reason this is a critical point is because the derivative equaled 0. Okay? If you have a 0 slope, that means you stopped increasing. So I'm going to say I'm increasing from negative infinity to 3/2, and then again from 3/2 to positive infinity. At 3/2, I am not increasing. I want to be very clear. I am not increasing or decreasing here. Okay? F is, and I need to justify, f prime is greater than 0. Okay? F prime of x is greater than 0. Is f decreasing? Obviously never. How about any relative extrema? Do I have any maxes and mins? Well, no. I can't have a max if I go up and I go up more. Okay, I certainly can't have a min. I didn't go down and up. I didn't go up and down. All my function is doing is going up. So what I want to do is try to sketch out what's happening here so you could visually see it. Basically, okay, when I get to 3/2, 1.5 there, I have this function that's increasing, and it has a 0 slope, and then it increases some more. So this function, and that's what this is telling us, this sign chart is telling us, is that this function is always increasing, but at 3/2, it's a critical point, so it has a 0 slope. So right here, I should have a horizontal tangent line. It's pretty neat. All right, now they're going to start to get a little uglier. So let's get our critical points. Set that derivative equal to 0. So let's go 4/3 x minus 3/3 is to the 1/3. Minus 4/3 x, if I subtract 3/3, to the negative 2/3. Now I have to set that, of course, equal to 0. Okay? Now, it's all that your favorite factor, and you got to pull out that GCF. Alright, so I can take out, I'm looking at this side of the minus sign and this side of the minus sign. I can take out the 4/3 x to remember to the smaller exponent to the negative 2/3. Okay, so when I write what's left, basically I need somebody left on this side of the minus sign, somebody on this side. So if I take out the 4/3 x to the negative 2/3, imagine subtracting negative 2/3, you're left with 1. So I get x to the first. Minus, if I took that out completely, I should get x minus 1. Okay, that's what I'm setting equal to 0. Now it might look ugly, but go with me here. Basically, I have my 4/3. This x to the 2/3 moves to the bottom, and I have the quantity x minus 1 on top. Alright, and again, that's what I'm setting equal to 0. Now remember, a critical point is when you set your equation equal to 0, but you also have to consider when the fraction does not exist. So when I have this fraction, I have to set both the numerator and denominator. Okay, so let me explain why again. I set the fraction equal to 0, that's really when the top equals 0. But a critical point is when that equals 0 and does not exist, and that's when the bottom equals 0. So basically, I'm going to take the top, 4 times x minus 1, set that equal to 0, and I'm going to set my bottom equal to 0. Okay, so if I factor that, I basically get x equals 1. If I pull this apart, that means nothing, and I get x equals 0. So I should have 2 critical points, one at 0 and one at 1. Make sure this gets labeled f prime and f. And remember, I'm plugging these into f prime. And I don't care what the number is, I just care whether it's positive or negative. So I'm going to start with the 2. Here is my f prime function. Okay, on top, 2 minus 1 times 4 is a positive, divided by 2 to the 2/3 is a positive times 3 is a positive. Positive divided by a positive is a positive. Now I've got to plug in a half. Okay, well anybody between 0 and 1, I'm going to use a half. 1/2 minus 1 is negative times 4 is a negative, divided by 1/2 to the 2/3 is a positive times 2, and a negative divided by a positive is that negative. And now I'm going to use a -1. -1 minus 1 is a negative, times 4 is a negative, divided by the cubed root of -1 squared is a positive. So I get a negative divided by a positive is a negative. So what does that tell me this function is doing? Well, it's decreasing, decreasing some more, and then increasing. All right, so let's rate our statements. I know f is increasing from 2 to infinity because f prime is greater than 0. Okay, so again, I'm looking at my arrow going up, describing it with calculus, the f prime line. I know f is decreasing. Now notice, again, you have to write it in 2 separate steps. You cannot say from infinity to 1, or negative infinity to 1. It is not decreasing at x equals 0. I am decreasing from negative infinity until 0, and then from 0 until 1, because f prime is less than 0. Now let me show you another little thing you can add to your sign chart here. Remember, the derivative equaled 0 at 1, so you could put a 0 above there, and then remind yourself that at 0, the derivative actually did not exist. Okay? So again, at 1, that's when my slope equaled 0, and at 0 was when my denominator equaled 0 or did not exist. And then lastly, I have a relative min only. Follow your arrows down, down, then up, makes a min. At x equals 1, f prime changed from negative to positive. Well, we're going to get a lot of practice over the next couple days with finding our critical points, and that leads into some heavier calculus that we'll get to later on. Have a great night. We'll see you tomorrow.